Hi sir, my name is Tarvin Anlaki Mukundan and my student ID is 101227622. Today I'll be presenting on the mechanical division of our project. So our project is intended to create an automated machine that will load data into USB flash disks in a bulk quantity. For this design, we got inspirations from couple of designs and couple of existing machines in the market today. One of them are 3D printer and laser engravers. So this 3D printer was a big inspiration for us because our initial sketch and initial idea for this project began with a similar concept of how a 3D printer performs and moves around. So the axis movement and extrusion frame all was inspired from the 3D printer. However, we could not finalize it because 3D printer's concept was more towards vertical positioning and we required horizontal positioning and moving machine. Therefore, we did more research and we came across a machine called laser engraver. This laser engraver is a machine that's somewhat similar to what design we would like to create for the project. Rather than using a laser engraver, we just had to remove it and add in a USB port and a USB loading port, loading bay, so the the motors can move around in different axes and plug in the pen drive and plug out it. So this laser engraver was one of the most unique and very similar concept of a machine that we needed for our project. On the timeline, at the beginning stages, I did some brainstorming to design this machine, and on the second stage, I had to do some sketches and drawing, and I discussed with my teammates regarding the models, and we also consulted the lecturer regarding the sketches. Once once I have finalized the sketch, I went on to create the 3D model of the machine in SolidWorks. At the fourth stage, the components from my teammates, such as like the electrical part, was added into the design, such as motors, limit switch, um, the 3D model of a Arduino board, and so on. At the final stage, we finalized the SolidWorks design, and we also have improved we also did some changes based on the calculation we have done to provide a best performing machine. As you can see, this is the mechanical design of the project, and this over here is the joint for the extrusion where it will be fixed and screwed together to hold the frame, and this is the pulley where the rollers will be positioned inside the extrusion, which allows the pulley to move freely across the extrusion track. So the entire machine was built using a frame which is made out of extrusion, which is 20 by 20 mm. So this extrusion is used mainly because it has a gap where it can perfectly allow the pulley roller to align on it and allows it to move freely across the axis. Therefore, our machine has a two-axis movement in our machine right now. So these are the main components that were used in our project. One of them is NEMA 17 stepper motor, which can provide about a 44 Newton cm torque, and it also has an inertia of motor which is 220 kg meter square. The gear pulley we used for this project is 2GT316, which has 13 tooth and a pitch diameter of 12.73 mm. The timing belt we used for this project also is 2GT timing belt because we want it to work together with the gear pulley. As you can see, the 2GT T16 gear pulley NEMA 17 stepper motor and 2 GT timing belt images are provided. So based on this information, we made a small minor calculation to find out what will be the torque that can be produced using the stepper motor and the gear pulley with the 16 teeth on the timing belt. So we managed to calculate it will be around 56 Newton cm per motor. And we have three stepper motors, and two stepper motors will be used for one axis to produce maximum torque to insert and plug out the pen drive, and where the other motor is used to move the port from one side to another. That's all from me today. Thank you, sir.